Right, hello and welcome. Let's have a look and see what we're going to do today. So today is going to be about coordinates, straight line graphs and all the rest of it. Right, so let's get cracking and do our graph. Now, obviously you can do this without graph paper. And we have two axis lines, and they are the X, which is the horizontal, and the Y, which is the vertical, and they're numbered from the center towards the outside, and this way we go positive and this way we go negative, and put your numbers on the actual lines itself, not in the boxes. 5, 6, 7. And when we're on the y-axis we go up in a positive manner and we go down in a negative manner. So there we have, going to do a few of these, so there's going to be a lot of rubbing out and drawing again. I'm going to split this up into a couple of videos this lesson. So the first we're going to look at is coordinates. Now coordinates are a way of representing where something is on the grid, on the graph, on a map, on anything else, yeah, by numbers. And we write this is a coordinate, and the first number on the left represents the X number, and the Y is represented by the second number. So always go along the X and then go up the Y, and this is where, and I'll call it point A. So we go 3 along and 5 up until we get there, and that is where point A is going to be, on that cross with 3 and 5. We do one in each corner, so point B, we'll call it 5 and minus 4. So we go along 5 and down 4, and we're down there. Point C, we're going to go minus 6 and minus 5. And there's a little comma in between, so all those don't get muddled up with a dot. These don't necessarily have to be whole numbers, by the way, but it's better when they are. It's easier, isn't it? So minus 6 and then down to minus 5 is going to be point C, and point D is we're going to do minus 7 and plus 4. So minus 7 there and plus 4, and there we have point D. Okay, so that's coordinates. Right, I rub that out because I need to draw something else. I don't want to keep doing too many of these. Right, so point B. So there's coordinates. So let's rub that out. Now, what's the next thing we're going to do? Right, so the next thing is going to be equations. Equations of lines. Now there are some very straightforward ones we need to remember. We would have to identify. I'll do it in green, and it might be that you get a line drawn for you there, and you have to do what is, no, it's not very good, is it? I bet do it in black. Turns out a bit better. So here's a line. What's the equation of that line? Well, see, you see it goes through the y-axis at 4, and no matter where you are on this line, it's always going to be 4 on the y. So regardless of the value of the x, you're always going to be 4 on the y. So this one is going to be y equals 4. Now you can have a vertical line, which I'll do that, and it goes through the x-axis this time at 5. So anywhere on the line, x will always equal 5. So that's going to be equals to 5. Then the next one to draw is, I hope we're going to get this right, I'm going to have to do this in 2 halves, is a 45-degree angle. that goes through the middle. Yeah, there. Now, if we look at a point on this there, you see that x is 5, minus 5, and y is also minus 5. If we look at that point there, we see that x is 3 and y is 3. So x and y are always the same, no matter where you are on this line. So this line is going to be x equals y. Now, the fourth one is another diagonal line, but this time the diagonal line goes through the middle this way. And again, it's at 45 degrees. And come down to the side there. Right, so let's have a look at this top left hand corner. If x is minus 7, y is 7. Therefore, they are opposite. One's a negative, one's a positive. Down here, the x is positive and the y is negative. So they're the same as each other in value, but they're opposite polarities. So this is going to be minus x equals y. It could be that you can have x equals minus y. It's exactly the same thing. So either of those two will do. And here you would be given lines on the question paper and it would say, what's the equation of that line? All right, now some lines are more difficult than others. So we'll move on to those and bear with me whilst I rub all these out. Otherwise it just gets messy if we've got too many lines all over the place. Right, so there's a lot to do. There's a lot involved in all these graphs and things. So I've lost my number 1, my red number 1, so we'll put that in there. Right, so let's have 2 points at random, and what is the equation of the line? Or shall we do the equation and then draw the line? Let's do the line and work out the equation. Okay, so we do a line from point A, which is going to be minus 4 and 2, and point B, which is going to be, say, 4 and 6. So let's do point A, which is minus 4 and 2, which is down there. That's point A. And point B is 4, 6. 4, 6. There. That's point B. So it may be that we're asked to work out what the equation of that line is. Now, the way we work out what the equation of the line is we have got this: y equals mx plus c. And this is the standard way that we will write what the equation of the line is. Now we know that all about the y and all about the x, but we've got 2 other letters here. So this is the gradient of the line, and it's represented by a particular value. Now, if this number is positive, it means the line goes uphill. Everything goes from left to right. So this line here is uphill. If it's a negative number, then it means it goes downhill, something like that. Now this is called the y-intercept. I might do it all in one go, the y-intercept. And this is where our line crosses the y-axis. Yeah. Now, that's the bit that we can do first. So if I come back to black, we can go y equals mx, don't know the gradient yet, and where our line crosses the axis is here, 4. So we're going to put plus 4. Okay, now we need to find out m, the gradient, to finish this off. So the gradient is done by working out the change in y divided by the change in x. Now remember, everything always goes from left to right. So let's work out what the change in y is. The change in height is either going up or it's coming, this way it's going down, this way it's going up. So we'll draw a line that goes up from the bottom of the line to the top of the line there, and then carry it on there. So the change in y is how many squares, but be careful of the scale that they've used. This might be 10, 20, 30, 40, 50, so be careful. So the change in y is 1, 2, 3, 4. So it goes up 4. So we'll put that as 4. And the change in x is from the left to the right. Remember, everything goes left to right. 1, 2, 3, 4, 5, 6, 7, 8. So that goes across 8. So 4 divided by 8 is the same as a half. So our final equation for this line is 1/2 x plus 4. That is how to find the equation of the line. See where the line crosses the y-axis, that gives you this, the c, the intercept, and then work out the gradient of the line by using change in y and change in x. Now, as an aside, you might not be given, let's have a look at over there, you might not be given the graph to look at. So we're going to work out the gradient of a line with no graph. Yeah. So point A is 2, 10, and point B is going to be 8 and 20. Now, this is the x, this is the y, this is the x, this is the y. Now remember, it's the change in y divided by the change in x. So the change in y is the difference between 10 and 20. It's positive because 20 is bigger, so we're going to go up 10. So that equals 10. And the change in x is from 2 to 8, which is 6. So that's 10 divided by 6. That was a bit awkward, wasn't it? So 10 divided by 6 is, let's do this. 10 divided by 6. 6 is into 10, go 1. Yeah, and we've got 4 over. And 6 into 40, go. This is going to be awkward, isn't it? 6. Yeah, so it's 1.6 recurring is our gradient, and that would be the m number. Yeah, m number. If we had point A is 10, 10, and point B is 5, 0, right? So the change in y over the change in x. So the change in y goes from 10 down to 0, which is minus 10, and the change in x goes from 10 down to 5, so this is minus 5, minus 10 divided by minus 5, oh no, the change in x, let's have a look, from 10 to 5, it's minus 5, that equals 2. So wonder why that's from 10 to 0 is the y, so that goes down 10. From 10 to 5 is the x, so that goes down 5. But the x is never a negative number. Yes, it is, because we're going the other way around. So we need to start at this end, don't we? The a's and the b's are the wrong way around. So let's, oh, terrible mistake. Yeah, that's because I've just made numbers up. So You can't go backwards because remember everything's got to go from left to right. So if we have A as 5 and 0 and B as 10 and 10, do it that way around. So the change in Y is plus 5 and the change in X, the change in Y is 10. Getting in a muddle here. The change in X is 5, so that equals 2. Yeah, so you can't go backwards along a line. I think that 5 0 is there and 10 10 is there. So I was trying to go that way, the wrong way around at first. So that is no good. I want to do a line that gives me a negative gradient. So if I have a negative gradient, I'm going to go from there down to there, yeah, in that direction. So I'm going to call this A and I call this B. So A might be 2, 10, and B was down here, might be 10, 2. Yeah. So the change in Y divided by the change in X. The Y is minus 8 and the X is plus 8. So that gives me negative 1. So that's a negative gradient going down. That's better. I had my A's and B's the wrong way around. Now, let's go back to the graph and wipe this out. And the next bit is going to be the midpoint of the line. Midpoint. And we can do this both with the graph and the midpoint. Right, so first of all we do it with this, to the midpoint. So A, we're going to do this, is 2, 2, and B we'll do 6, 6, 6, 6. So 6, 6 is there. And we would draw this like this, so we'd have A and B. And the midpoint of this. Now, what we do, we have to find somewhere that's going to be in the middle there. So what we do is we add the x's together and divide by 2. So for the x, we've got 2 plus 6 divided by 2. And this is finding the average. So it's 8 divided by 2, which equals 4. And for the y, it's going to be 2 plus 6 divided by 2, exactly the same, yeah? Which equals 4. So our midpoint is going to be 4, 4. Right, and there, look, 4, 4. There is our midpoint. So finding midpoints, you add the x's and divide by 2, and then you add the y's and divide by 2, and that will give you your coordinate. Now, we can do this one again without the graph. So we've got A is 0, 4, and B is going to be 10, 20, yeah? So wonder what the midpoint is. So add the x's together, which is 0 plus 10, divide by 2, which is 10 divided by 2 equals 5. So that's the x. And the y's is 4 plus 20, divide by 2, which is equal to 24 divided by 2, which equals 12. So that's the y. So our midpoint now is 5 on the x and 12 on the y. That's how to find the midpoint. Now, let's go back to the graph for a next bit. And this is where we're going to draw a line with being given an equation. I've got some examples, if you want to stick with this to the end. I've got 3 of them, various difficulties. So if we're given an equation of y equals 2x plus 1. Now, instead of having the line and finding what the equation is, we've got the equation, we need now to draw the line. And this is where we have a little table. So you have a table of x and y's, and it is like this. There. And you only need 3 things. And the simplest numbers to put for the values of x is 1, 2, and 3. Now, okay, so what we need to do is substitute the different values of x into this equation, and we will be able to work out what the y is for that particular value of x. So we do the first one, yeah, which is y equals 2 times x, which is this one, 1, plus the 1. So it's 2 times 1 is 2 plus 1 is, so y equals 3. So there is the value of y when x is 1. So we'll plot that 1, 3. We do the second one. We'll put the number 2 in there. So now y equals 2 times 2 plus 1, which is 4 plus 1, which is 5. So this is now 5. So when x is 2, y comes out to be 5. So 2 and 5 is there. Now the third one, we'll put the number 3 in there. So y equals 2 times 3 plus 1, which is 6 plus 1, which is 7. So this is y is 7 when x is 3. So 3 and 7. Now look at these lines very carefully, and if the 3 coordinates that you've plotted line up, you know you've done it correctly. So all you need to do with your ruler then is just continue to draw the rest of the line. I'll do it in 2 bits, yeah. So as long as I get it straight enough, something like that. Now, in the question, there is normally a caveat that says, draw the equation of this line with x values between -3 and 3. And what this does, I'll come down a bit so I can actually see that. What this does, it gives you the end of the line. So you must not go further than -3 on the x, and you must not go further than 3 on the x. So it's between these 2 lines. So you've done it in pencil in the exam, and then you've gone back and you've done that. You remove all the excess line. So these are the limits of your line, -3 and 3. For the x values, they don't bother telling you the y's, but it's just -3, stop, +3, stop. Draw the little table. Okay, so now we look at some proper exam style questions. Now these are from past papers, so 15, 17, 28. The higher the question number, the more complicated it should be. So let's have a look at this. So the graph of, I'll do it in red now, the graph of y equals 4 minus x for values of -2 to 5 is shown. So this is our y equals 4 minus x there. And you see it's gone from -2 and it stops there, and +5 and it stops there. So they've done one for us. Now, on the grid, draw the graph of y equals 2x minus 5 from the values of -2 to 5 again. So this is where we use our table. So we have x, we have y, 1, 2, 3. You may be wondering why I've chosen 1, 2, 3. It's not random, it's just that 1, 2, 3 are the easiest numbers that we can work with, and it avoids any negative numbers. If we could use any numbers we like, we could do -5 plus 10, 20 if we wanted to, but as long as the three coordinates joined up then are in a straight line, it's fine. These are the easiest numbers. So the first one we're going to look at is to put the value 1 into this. So this will be y equals 2 times 1 minus 5. So 2 times 1 is 2, 2 minus 5 is -3. So when x is 1, y is -3. So I'm going to plot that there. 1 minus 3. And look what they've done here. Look, 1, 2, 3, 4, and they've gone 2, 4, 6, 8. So they mix up the scale, so you're not just counting the big squares. So let's put 2 in there. So y equals 2 times 2 minus 5, which is 4 minus 5, which is -1. Minus 1. So we're going to go 2 minus 1, which is about there. Yeah. And for the third one, we're going to put 3 in place of the x. So y equals 2 times 3 minus 5, which is 6 minus 5, which equals 1. 1. Right, so when x is 3, y is 1. X is 3, y is 1, which is there. Okay. Now, they look as though they're in more or less of a straight line. Not the world's best at doing these, but especially not with a ruler, it would be much easier, yeah? So I'm going to do that and come the other way, more or less a straight line, yeah? Now remember, it's from -2 to 5, so don't go beyond those parameters. So -2, so we're going to stop there, and 5, we're going to stop there. Otherwise, we'll lose marks, yeah? Now, so we've managed to draw ourselves another line. So what are we going to do here? We're going to do, use your graph to solve 2x minus 5 equals 4 minus x. Now, don't worry, it's not that complicated. Look, 2x minus 5 is that one. The second, the red line that we drew. 4 minus x is the first one. See, y equals that and y equals that. Now, when these two equal each other, it's just the same as saying where they cross. The y value will be exactly the same for both of these. So where these two cross is the y value, which is there. And that looks like where they cross, the y is 1. So that equals 1. Now, just to prove that, 2x minus 5 equals 4 minus x. And if we did the algebra way, which we're not allowed here because we've got to do it in the graph, we would add an x to both sides, which will give us 3x minus 5 equals 4. Then add 5 to both sides, which will be 3x equals 9. And then divide by 3 both sides, so x equals 3. Oh, I've got to find the x value, not the y value. I'm so glad I did that. Yeah. Not reading the question properly. Yeah. I want to find x, not y. Right. Okay. So x is actually 3. So that was a good job. I checked that because I didn't read the question properly. But if you do this, make sure you don't do it on the same piece of paper and do it very lightly in pencil, because they don't want you to do this. They want you to look at the graph, find the x value is 3. It's so easy, isn't it, when you actually read the question properly? Oh, dear. Right, okay, so that's that one. So now we go to question 17. So what's question 17? There's a bit of a long one here. Right, it's about this one. So draw the graph of y equals 3x minus 1 for the values from -1 to 3. So -1 to 3 are the ends. So let's write down y equals 3x minus 1. So let's use our little grid. There, and there. And we got x and we got y, and 1, 2, 3. Plug in 1 to that one. So y equals 3 times 1 minus 1. 3 minus 1 equals 2. So y equals 2. Second one, y equals 3 times 2 minus 1. So that's 6 minus 1, it equals 5. So that's 5. And the third one is y equals 3 times 3 minus 1, which is 3 threes are 9, minus 1 is 8. So 8 in there. And the other thing to mention there is, see, for every one that y increases, that x increases, y increases by 3. So you can predict what they are anyway. So you got 2 plus 3 is 5, plus 3 is 8. So the next one will be 11. Yeah, 4 and 11. 5, add another 3, 14. So once you've done a couple of them, you can, do as many as you like if you want, but you only need the 3. So 1 and 2. 1 and 2 is there. 2 and 5. 2 and 5 is there. And 3 and 8. 3 and 8 is going to be up there. There you go. So now we can draw the line. So I'm going to go from here up there. I'm going to do it longer because I'm just going to rub it out when I get to the end. And down there. Oh, where are we going to go? Minus 1. So, we'll call it there. It would be perfectly straight if I used a ruler. So now we've got to do the parameters. So let's rub out the bits that we don't need. So anything beyond plus 3 we don't need, and anything beyond minus 1 we don't need either. So there you go. So that's that one. Yeah, question 17. So we're fair way through the paper. So this one might be harder because it's a question 8. Now what are we doing with this one? Now, a straight line has a gradient of 4, right, and passes through the point 523. Work out the equation of the line. Now, we're using y equals mx plus c. Now, the gradient is 4, which is this number. So we can now go 4x equals what? Y plus c. Now we have to find out what c is. Where does this line cross the y-axis? We don't know because we haven't got a graph to work from. But we have this information. We have a value for x and we have a value for y. So we can put those in to find out what c is. So the y is 23 and the x is 5, so that's 4 times 5, and then plus c. So 23 equals 20 plus c. Now a bit of algebra, let's take 20 away from both sides, so that will be 3 equals c. So the answer is, work out the equation of the line. So now we know what c is. So I nearly thought that was the answer. So we have to go back to y equals, the gradient is 4x plus the c is 3. So there's the gradient of the line. Okay. One other thing to mention on this sort of thing is parallel lines. Parallel lines have the same gradient. Therefore, if this line was y equals 4x plus 3, and the 3 is where it crosses the there, this line would be y equals 4x, say, plus 5, because it crosses that y-axis a bit higher up. So the only thing to do that you need to know here is that if you have the same number, be it positive or negative, in front of the x, then these are parallel lines. Okay, so we can